So now that we have a full understanding of what links are, let's look at how we go about creating them. There is a program expressly designed for exactly that, and it's called LN, which of course is short for link. How do we use LN? Well, we use it in an absolutely identical way to the way we use copy, CP, except that the file of course is not copied. There is no duplication of data. All we do is create another reference to the same file, or if you like, another link to the same file. So let's go and have a look now at how to use the LN program. Okay, notice that we have a file called sample.html. Now I could of course duplicate that file by using CP, copy sample.html to copy. Let's just call it copy just so that we know what we're looking at. And that duplicates the file. Now I do an ls-li and I find, well, there's so many files. I'll just list the two files we're interested in. Okay, there are the two files, and you'll notice that they are almost identical. They both have the same permissions, the same link count, owner, group, same size, slightly different date and time, which is our first indication that they're not identical files, but they could even have the same time on them. So how can we tell that they are in fact different? Well, of course, the inode number is different. So obviously now if I go in and modify sample.html, and then I were to open up copy.html, I would find the original text. So now instead let's create a link, ln of sample.html, and I'll call this link.html. Now when I list the three files that I'm interested in, I find that the link count for sample.html has gone up to 2, and of course there is a second file that shares exactly the same inode number called link.html. I think you recall from an earlier example that if I were to modify sample.html, I would go into link.html and find that the data has actually changed. Also, of course, I could create a link to sample.html in a different directory. I could put one in subdir1, and now I could go into subdir1 and do an ls-li and find that there is of course a file in there called sample.html as well, again with the same inode number, and now there are of course 3 links. So yes, it is possible to have 2 files with the same name in different directories that are in fact links to the same file. Okay, so hopefully we now completely understand what a link is and how to use one. What we probably don't yet fully understand is why do we even have links at all? What's the point? Why were they invented? Can you think of a reason? Why don't you just pause the video just at this point and see if you can come up with a reason as to why links were created. So, what did you come up with? Well, I'll give you a very simple and straightforward answer, and this is the main reason that links were invented. Convenience. To make our lives easier, to make the user's life easier. And can you think of a way that it might actually make our lives easier? Well, I'll answer that by showing you an example. I've just chosen a random file from all the files on this Linux system. I've chosen the file yesno.c. This is in the directory called /user/source/linux/scripts/lxdialog. Now, let's suppose that this is a file I'm very, very interested in. Perhaps this file changes on a daily basis, and I'm always interested to know what is the latest thing that's going on in this particular file. Can you think of a file in your workplace that changes on a regular basis and you'd always like to know what's going on with that file? Maybe the receptionist keeps track of the extension numbers of everybody in the company and she updates that on a regular basis. Now what you could do, I guess, is copy that file that you're interested in into your home directory. The reason for doing that is you might be very, very sick of always having to type /user/source/linux/scripts/lxdialog if you want to actually access this particular file. So you just copy it into your home directory and then you can access it very easily. Now of course if you copy the file, then if the secretary goes and changes the file or the file is updated in some way, you will be running an old version of it. You will be accessing a copy that was made sometime in the past. Not only that, but you're wasting disk space by duplicating the data in the file. Wouldn't it be much nicer, of course, if you simply linked the file into your home directory? And I'll do that now. I'll ln the file yesno.c into my home directory, which is just tilde. And of course it's giving me an error message, invalid cross-device link. That is because the yesno.c file and my home directory are both on different disks, both on different hard disks. And because they're on different hard disks, they're obviously going to have different block numbers, which means they have different inode numbers in different inode tables, which means I can't link them, which is a bit of a shame. But you get the idea. I would have been able to link it, and then I would have a file called yesno.c in my home directory, which was an exact link of the yesno.c in user source Linux scripts lxdialog. Now, please understand that simply putting it in my home directory does not give me access to the file that I didn't have before. If I was not able to read the file or modify the file in its original location, then there's no way I would be able to in its new location in my directory either. The reason for that is, if you recall, that permissions are the same on all links to a file. So I don't violate any security protocols by linking that file into my home directory. I just make it more convenient for me to access it whenever I want. And of course I have the added benefit that I'm not duplicating disk space by creating a copy of the data. There's still only one version of the data. So if your organization is one of those that suffers from a massive glut of people copying files from place to place, you might like to consider linking files instead of copying them. And of course dramatically cut down on the amount of duplicated data that is on your hard disk. Okay, well that's just about it for links. In the next module we'll have a look at a special kind of link called a symbolic link.